Hello and welcome to Advent of Code. Getting ready for day 11 here, about 30 seconds left. Our Advent calendar is filling up, and you can see that starting to get some words in here, depending on how the refresh goes. Here we have an internet. I've seen some magic and a couple other words, so this is exciting. It's fun to refresh and see what we've got. Have Eclipse ready to go here, close your environment. About 5 seconds now. So let's see what we've got. Barely, oh boy, hex grid aligned. All right, I know what a hex grid is. Here's my puzzle input. Okay. All right. Let me just ask real quick how many lines are in input. So it's just one line. Okay. The question is, have to determine the path the child starting where he started, fewest steps. Okay. The hexes. Okay, this is 3 steps away. All right, I think I got it here. So there are a bunch of different directions. So let's take the input here. Let's split it by commas. Let's see how many of these there are. And then what are the frequencies here? Okay. Yeah, okay. So let's also trim this. Okay. So, I think we just sort of have to, for each of these here, I think we just have to say what these represent in terms of changes. So this is like -1 here, and -1 here, something like this, and like -1 minus, or like -1 plus 1 here, 1 1 1 0, and finally 1 minus 1, something like this. So then I think you can say for AV, well, actually, I think you can just do like map, just call this function here. This is a function in line. Okay, and then apply where are you supposed to do this here? First, I guess, apply plus here, and then like maybe map second. This. Map first. Second. Like that. Let here. So what would this give? Okay. So the only thing I don't know if this just, let's just at least see if it gets the right answer for something like northeast, northeast, northeast is 3 steps away. So this isn't gonna be quite right. I think that this is actually going to be the position. It's just that we have to sort of, I think we got to kind of like take like the difference here. So 290 and like add it to the 451. It's something like that. Okay, then maybe this is just saying that because we're this many away from the origin, it must be that many steps. Let's try it. Not the right answer. Okay, so this, I know this will give us the right answer. Northeast, northeast, south, south. So if we have something like this, and instead of our regular input, have this here. Okay, ignore you for now. Split. Oh, right. Yeah, let's comment all this out here. Okay, then replace this with this. Okay, this should be all right. All right, so this is 2 steps away. And then this, try this here. Okay, so here, the answer needs to be 3 steps away. All right, so why? Why is it 3 steps away? It's because if you go southwest, southwest, southeast, southwest, southwest, then you can go south, south. Okay, so I think, yeah, we're like representing this not quite right. I think that like a south is kind of like a full step, whereas like a southeast is like half a step. Like this. This makes more sense. Okay. Okay, put you in here. All right. Now this gives 3 steps away. Okay, so I guess you sort of have to add the absolute values, maybe. Any 3 steps away. Okay, so it seems like you have to add the absolute values. So let's turn this off. Okay, so I think I can just add these. 805. Right answer, rank 49. All right, next step. How many steps away is the furthest he got from the starting position? Okay, so let's see. So I think we want to use our reductions here. So step, state, dir. We're basically going to say that the state is the position. Okay, take this map, apply it to the direction, and then, okay, so this is going to be, we'll just call this x and y, and then we're just going to return a vec map plus xy here. This is right. And then we do something like reductions step starting at 0, 0, working over these values. Take 5. No. Reductions over step. Here we go. Okay, this looks fine. And then so for this, we basically want to map. Okay, so for some xy, you just want to add. There's ABS here. ABS y. Map this. Okay. Okay. And then apply max. All right. Got an answer here, 1535. Right answer, rank 45 again. Okay. Well, pretty fast day. Yeah, let's take a look at the advent calendar. Oh yeah, very nice. Ooh, we got Ethernet, pretty cool. Refresh again. We got PR2C0-G, or maybe POR. All right, not sure what that is. Yeah, let's take a look at the stats. I think yeah, it looks like we were able to get some points today. That was good. Was it enough to get us on the leaderboard? Not yet. Not yet. Let's see. Let's see. We have 268 points, and the bottom of the leaderboard is 324. So more work to be done there. But let's talk about the problem. Go this way. Okay. So this is a problem about navigating a hex grid. So if you've played board games, then you're probably familiar with hex grids, like Settlers of Catan, for example, is a pretty prominent example of a game with a hex grid. When you're at this point right here, there are typically 6 directions that you can move in, the 6 edges of the hexagon, and it basically gives you a series of steps that you take here, and it asks you after you've taken all the steps, how far away are you? So for my implementation, I basically represented each of the steps that you could take as a pair of changes to the x and y coordinates. Initially, I had my basically the combo directions implemented in the wrong way. But I think one of the things is that the sum of the absolute values of this vector always is 1. So then my first implementation was just to take the input, split it by commas, and then I basically sort of just mapped this to the whole map. And what I'm doing in that situation is I'm pretty much treating it like the order doesn't matter, right? If you go like north and then northwest, that's the same as going northwest and then north. So that's how I treated it. And then and then I just applied plus to the first of these and applied plus to the second of these, and then that gave me a position, and I was able to feed that in, got the right answer. And then in the second step, what's the furthest that he got away? And so I just made a little quick helper function here that just sort of applies to your current position, the direction that you're in, and another helper function here that sort of returns the distance from the origin that you're at. And I just said take all the steps, get the distance from the origin at each step, and then take the max one of those. So straightforward. Happy to have gotten some points. Had a lot of trouble yesterday, so I'm glad that today is a little bit quicker and better performance. And I hope tomorrow's problem goes just as well or even better. So that's all I've got. Thanks for watching.